Don't freeze.
Thank you. All right, so we're starting a new section. We'll talk about compounds and specifically ionic compounds today. If you did poorly before, here's your chance to get caught up and start a new section and do all the work and do well on the test and not fail for the year. I'm going to do a little flow chart here. Top middle, so in the middle of your page, write the word matter. Let's put a box around it. That makes it look more important. And then below, this is going to get broken down into two categories. On the left, we're going to have pure substances. So you guys are familiar with the word matter, right? Matter is stuff, right? Anything you can touch, feel, or smell, solids, liquids, and gases, all the stuff that you see or you have, all that's matter. That's really the best definition there is. If I give you the book definition, it's garbage and it won't mean anything to you. But anything, all stuff is matter. So we break it down into pure substances and this other category over here. I'm just going to put a blank box there and I'm not going to tell you what goes in that. Because I don't want to. Pure substances are broken down into two categories. Elements. Well, actually, I don't want to. It's that if I tell you two different things that are, similar to each other, then you'll mix the two up afterwards. So I would never tell you two similar things in the same day. Pure substances are broken up into elements. That's what we spent the entire last chapter dealing with, or most of the last chapter. They're the things on the periodic table. Elements are pretty simple. If you want to, below this, skip a few lines. I'll give you the definition for elements. My definition, anyway. Elements, you should write this. Skip about, there's going to be one box here and there's going to be two below it. So below this, leave enough room for like another level on the flowchart. Elements are made up of only one type of atom. So for example, if I had a gas tank full of neon gas, it would only have neon atoms in there. That's the only thing that would have. I mean, you're never actually going to get completely pure, but if you did, that's what it would be. So it's like the purest of the pure. There's one kind of atom that makes up everything in that container. On the other hand, we have compounds. And you've heard the word compound before. You know what a compound word is. You stick two words together, you get a compound word. Well, here you stick two elements together, you get a compound. So, compound is made up of two or more elements chemically bonded. This is like you take two elements, you put them together, there's some sort of chemical reaction, they come together and make some new substance. That's a compound. Elements would be what? Elements would be like hydrogen, helium, nitrogen, right? Just things on the periodic table. Compounds, you would have a formula that's more than one thing. There would be more than one element in it. So for a compound, actually you probably can't see this on the video, so let me right over here. So a compound would be like H2O. There's two elements in that compound, hydrogen and oxygen bonded together. NaCl, sodium fluoride. Whatever. Could be sodium iodide. Anything. So anything where you see a formula has more than one symbol in it, more than one element, then it's a compound. And then compounds are broken down into two categories. One's called ionic compounds. And on the other side, you're going to leave a blank box. And then maybe 3 days from now, we'll talk about the other types of compounds And then after we finish this chapter, we'll talk about the other side of matter chart, which is not pure substances. Okay, so let's focus on ionic compounds now. Ionic compounds. So this is, let's get rid of the S. Compound made up of a metal and a non-metal. Or at least this is the definition I want you to go by. So if we look at the periodic table, really wish I had, okay. Well, I'll insert it into the video afterwards. This stuff here, groups 1 and 2, these bottom groups, these groups here, and these orange ones, these are all metals, right? All this stuff. Hydrogen and this stuff over here are non-metals. So if any one of these bonds with one of those, we get an ionic compound. So sodium bonds with chlorine, we get sodium chloride, that's ionic. Or sodium chloride, or sodium bromide, sodium bonds with any of this. Or magnesium bonds with chlorine, magnesium chloride, or magnesium bromide. Any one from this side and one from that side together makes an ionic compound. So, table salt, sodium bromide, sodium iodide. I just like sodium, that's why I keep doing that. Any metal and any non-metal would work. All right, what do I want to do next? Oh, let's add on to this. So part of this definition here, the metal loses one or more electrons, comma, the non-metal gains one or more.
Using beans.
No?
Yeah.
You sure?
Yeah.
Oh,
right.
No E? Alright, that?
Yeah.
Should have hit English something.
Alright, I need some space. This one's wet. Where's my English? Okay. Alright, so let's think about what happens when we have this kind of reaction. Let's look at two atoms. Let's say we have sodium, 2, 8, 1. So this is a sodium atom with its electrons. So let's say it reacts with a chlorine atom. Chlorine 17, that's 2, 8, and 7. So these two come near each other. And nonmetals like chlorine, things on the right side of the periodic table, have a very strong pull on electrons. Whereas metals, things on the left side of the periodic table, have a very weak pull on their electrons. So this chlorine is going to steal this electron from the sodium. It's going to go into chlorine's outer shell. And then we're going to have ions. They're both going to have charges. There's one lost an electron and one gained one. So what we're going to have after this reaction, and this is the chemical reaction, this part here, we're going to have sodium 2 and 8. It lost its electron, now has that full outer shell of 8, and now it has a charge, +1, because it lost an electron, now has more protons than electrons. Then chlorine took the electron from sodium, and now it has an extra electron in its outer shell. And it has 8, it's full, right? Remember the octet rule? They're always going to gain or lose until they have 8. And it has a -1 charge because it has an extra electron. With me so far? Okay. Since they have a charge, they're attracted to each other. This is positive, this is negative, opposites attract, so they come together, they get stuck to each other. That's an ionic bond. Now, once this happens, well, let's erase all this.
Oh wait, were these ions up there?
This one?
Yeah.
Okay. Okay, so once this happens, and this happens to all of them, right? I mean, most of them until you run out of one or the other. What you have is, let's say you have one sodium here, and it's got a plus charge. You can call this network structure. So this is the structure that's formed. So you have a sodium ion, it's positive, right? And so what's going to happen? Well, it's floating through a bunch of positive and negative ions. Well, the positive ones are going to get pushed away, and the negative ones are going to be attracted to it. So, in this case, it's chlorine. So a chloride ion comes over here, another chloride ion comes over here, and all around it, these chloride ions are bunching up because they're all attracted to this positive ion. And so what's going to happen after that? Well, all these negative ions, these anions, are going to attract more positive ions, right? Because these positive ones are attracted to the negative ones. And what you're going to end up with is basically a checkerboard, where every other one is plus, minus, plus, minus, plus, minus. Oops, that was supposed to be a minus. And this is the network structure that's formed with ionic compounds. This is important because since all the ions are attracted to each other, that means ionic compounds end up having very high melting points because it's hard to push these ions away from each other, right? So, who wanted this still? Everybody caught up here?
I need the last one.
All right, I'll leave that. I'll write down here somewhere. So, here's my space to write. So, properties of ionic compounds. I'll slow down for a second. I need to start erasing somewhere. At least because it's the first day back, I'm all excited to get a chance to teach again.
It's the first time I've written
Good. Excellent. I mean, it's upsetting that, you haven't written yet. I don't know what the other people are doing. That's pretty sad. Well, English is nothing important to learn anyway.
Are
you gonna finish the?
I'm going to leave the blank spaces, and then I'll finish the flow chart when we talk about the other topics that go into those blank spaces. I have this thing where, I always think students are going to confuse things, so I make sure I don't talk about things that I don't want you to mix up with the things that I
How
have.
would you put like a chart like on a different page from all the items? Like what I must have ordered.
Well, I will. I'll do the chart again when I do the other stuff.
So we're gonna have to make a brand
So I
new chart?
Yep. Trust me, my way works. Not my first day. I know what I'm doing. Okay, so properties of ionic compounds. They have high melting points. And that's because of this network structure, because all the ions are attracted to each other. And also, because of that, they tend to form crystal solids. So when I'm talking about these, you should think about salt, right? Sodium chloride, what's it look like, little crystals, right? And I think that's all I'm going to give you. So if I ask you on the worksheet, why do they have high melting points? Because the particles are attracted to each other. This is something you should be getting by now. If the particles are not attracted to each other, have a weak attraction, then you have something with a very low melting point. Because melting and boiling means you're pushing the particles farther away. On the other hand, if you have particles that have a strong attraction for each other, then you're going to have something with a very high melting and high boiling point. It's very hard to push the particles away from each other. So in this case, ionic compounds, high melting points. The other things that we'll get to that other blank space, they will have low melting points. Questions?
We're done.
You're done.
Wow.
All right.